what is cloud computing? And if you read the statement by Larry Ellison, I'm sure we all know Larry Ellison, the chairman of Oracle. And Oracle was one of the early opposer of the cloud computing. They did not adopt the cloud computing considering it might fail. It's not the right concept. So they were a little lagging in the cloud adoption. But soon they realized that, okay, no, we need to adapt. And then they went full strength. They have most of the offerings available now in cloud. They are focusing a lot on the cloud. They have tied up with most of the cloud providers, and their services are available on cloud. So they started a little late, but now they are coming up and providing in a way to overcome that part. But early part, what Larry Ellison said is, it's interesting thing about the cloud computing is that we have redefined cloud computing to include everything that we already do. I can't think of anything that is not cloud computing with all these announcements. So he says, everything I know, people say I'm a cloud. So considering this, the compute industry is the only industry that is more fashion driven than women's fashion. So he had a very good point. I won't deny it, but yeah, that was taken as a negative. But he had a very good point, which say the people are not understanding cloud. Everybody says I'm using cloud. Everybody says this is the cloud. Now, with this, I'd like to ask you, what is real cloud? And Larry Ellison's question or the point goes very well with this slide. See, if you are using Gmail, you would feel, okay, cloud is something like a email service. If you are using Amazon, you will feel that, okay, cloud is something like a infrastructure service. That's more like a few blind men and an elephant. Somebody touching its tongue, it would feel something, or the trunk, it would feel something like a sphere. Somebody touching its legs, saying like it's a tree. Touching like a tail, say it's like a rope. So everybody would have a different visualization or thinking about the cloud computing. And that's why I brought out all the points about the cloud. I built the hype about the cloud to ensure that we know what is the hype in the market. At the same time, we should know what is real cloud computing. This is a definition by NIST, and if you are writing something in a theory, you should go with this thing. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resource that can be rapidly provisioned and released with minimal management effort or service provider interaction. The cloud model promotes availability and is composed of 5 essential characters. Let me give you my own definition. Any business service, understand, any business service which is offered to you on a pay-as-you-go model over internet, which is available whenever required, uses the resources optimally, and scalable, is called a cloud computing. Now, I guess that may be little different or little easier to understand. So I repeat myself. Any business service. Now that business service is what? It can be an email as a business service, an infrastructure as a business service, a collaboration as a business service, a messaging is a business service, database is a business service. Any business service which is offered to you on demand over internet, which is available. So something offered to you on demand. So whenever you require, it's available over internet, which charges you on a pay-as-you-go model. So whatever service you are consuming, it would charge you only for that, not for anything extra. And uses the resources optimally. So that part I'll cover in the next slide. So optimal resource utilization and a scalable service. So I hope this makes it a little clear for you. Any business service, so again I'm repeating because that's my major purpose of the today. I want to clear the concept of the cloud computing. Any, so now you can think of something you are offering like a database as a service, like email as a service, like infrastructure as a service, collaboration as a service, something CRM as a service, anything you are offering as a service. Now any business service which is offered over internet, again the words may be here and there, so because this is not a theory, words may be here or there, which is offered over internet, available on demand. So whenever you need, it's available to you, It charges you on a pay-as-you-go model. So whatever you are consuming, it would be charging you as per that only. It's a scalable. It should be scalable. That's one of the key aspects of that. It should be scalable, and it should be using the resources optimally, because then you should have a better cost calculation and every mechanism over there. So I hope this clears some concept about the cloud computing. Are you all clear a little bit more? Any doubts? So now when you go to the market, you would feel that, okay, somebody says Amazon is a cloud provider, Microsoft is a cloud provider. Then you can see, okay, which service they are you offering? Okay, they are offering online documents like Google Docs. They are offering the documents online. Like for Gmail, they are offering the mail as a service. Over there, the document as a service. In Amazon, it's an infrastructure as a service. Now, how does it meet the other characteristic? I'll come here next slide. So, going back to our definition of Forrester, why I brought out that only and not others, it meets some of our requirements. So if I now try to simplify in the same way, such as a form of standardized IT-based capability, such as internet-based service or software or IT infrastructure. So if I make it in a simple, any business service. So first statement, a form of standardized IT-based capability such as internet-based service, software or IT, I'll call it any business service offered by a service provider. Again, I'm still any business service available over internet protocol. So it can be internet or intranet. It's there. Which is available and scalable. So available and scales automatic. So which is available and scalable and pay per usage basis. Now, does the Forrester definition make sense for you? So that's why I simplify the service in a way. The first line almost is like any business service which is available over internet. Now I don't go on a protocol. It can be internet or intranet. Available, scalable, and pay-as-you-go model would be there. Right? Again, coming back to NIST, I don't focus on the first 3 lines. I focus on the one aspect which is very important, is a 5 essential characteristics, 3 service models, and 4 deployment models. Now NIST stands for National Institute of Standard and Technology. That's a standard available of your governing body, and if you are going in a theory, this is the right definition you should go. But in that case, you will ask, what are those 5 essential characteristics, or what are the 3 service models and 4 deployment models? So that's what makes a cloud computing. These are the 5 essential models of the cloud computing. First one is a broad network access or ubiquitous network access, or if I in a simpler language, something which is available over internet or intranet. That's the key, one of the key attributes of cloud computing. Cloud, it's not like a client server kind of application or desktop based application. It should be available over internet or intranet to everyone. So generally you cannot touch your cloud. It's a cloud. Again, the term cloud has come from a different perspective. It's not from this way, but generally you cannot touch your cloud. You can just feel the cloud by connecting over the internet. So that's the broad network access. Second important aspect is a rapid elasticity. Now with that, I'll start again with one of my favorite examples. February 21st, 2010. I believe I'm right on the exact date. It's the 21st or 24th. India saw one of the milestones. Sachin Tendulkar, I'm sure that's a favorite for quite a few of you, and one of my favorites. He hit first ODI double 100. I'm talking about ODI double 100 in Nagpur against South Africa. And our focus today is not about that cricket. I'm sure you must be following all that. But why this is coming here is, I'm sure you might have visited, if you are following cricket in one or another way, you might have already visited a site called Cricinfo or ESPNcricinfo.com. That's one of the best sites for you to get your cricket scores, and I'm sure most of you are following that over there. They say their normal visitor, everyday average visitor count is 4 to 5 million users. 4 to 5 million users. On that day, what was the count of visitors? Can you imagine? On that day, the number of visitors on their site was 45 million. So their site broke down, and they had to publicly come out. The Samit Bal, the editor, had to publicly come out and say, see, we don't underestimate your love for Sachin, but yeah, we didn't anticipate this much of a load. 45 million, so it was almost 10 times load. And what they had to say, on that day, Sachin broke lot of records, but he also broke down their website. The click info was down, and that was the reason. Because of that, they were not having the enough infrastructure. So that's our point of focus today: the infrastructure, or scalability, or elasticity. Now, rapid elasticity would be whenever you require, it should be able to stretch up the resources as per requirement. So today you have 5 million, then you have 10 million, then you have 15 millions. It should work for you. It should provide you some scalable infrastructure to stretch up and work for you. Now, elasticity and scalability has a different concepts. They are not equivalent, or they are not synonymous. And what the exact difference in terms of cloud, I'll cover on day 4 when we go for the scalable services. But coming to here, the rapid elasticity is some service, like it can provide you a scalable infrastructure which can be elastic, so as per requirement it can stretch up over there. Just a second. So that's the second key attribute of cloud computing. It should be rapid elastic, so whenever required it can stretch up more resources, it can be able to provision more resources. That's the one of the key attributes of a cloud computing. So if you say I need some environment, and then suddenly from 5,000 users it reaches to 15,000 users, if your application fails, cannot cope up the load, it means it's not a cloud environment. Yes, I do understand that cloud would have its own limitation also sometimes, because suddenly from 5,000 to 20,000 it may not be able to manage well. But if it's a gradual rise, it should be able to manage over there. Third point is a measured service of pay as you go. So we talk about that. First one, when you say any business service which is available over internet, which is scalable, so we talk about the scalable and elasticity, and which charges you on a pay as you go model. Now, so in that case, whatever service you are consuming, it should charge you. So suppose you procured a laptop or a desktop or something, you procured a 500 GB hard disk at 3,000 rupees. You procured a 16 GB RAM at something 5,000, 8,000 rupees. Now out of this, if you are using only 2 GB RAM and only 100 GB hard disk, you can't tell the seller that unless I use 500 GB completely, I will not pay you. That will never happen. But in cloud, it does. You procure only service you require. So you say I need only 100 GB hard disk, so you procure 100 GB, and Amazon or any SaaS service provider would charge you on your 100 GB only. You need 4 GB RAM machine, you procure 4 GB RAM machine only. Yes, in future you can always change from 4 GB to 16 GB. There are the ways available. We'll see in our demos. So this way, Amazon or any service would charge you on a pay-as-you-go model. So whatever the service you are using, based on that only it will charge you. It will not charge you more than that. It's an on-demand service. On-demand means whenever you need, it's available to you. So suppose you want to procure any environment, any infrastructure, how do you normally do that? So if you want to procure a server, a laptop or desktop or something, you generally go in a case where you research over the net, or if you are a corporate, you would ask your vendors to provide a PO. You find what is the best PO, you procure, you place the order, then you receive the infrastructure. That takes what? How many? starting from 3 days, I would say, or 4 days to 3 weeks, 4 weeks, 6 weeks. I'm sure you agree with that aspect, because it's not an easy process. You need to do research, what is the right configuration. In cloud, it should take 2 minutes, 5 minutes, 10 minutes. The environment is available to you. That's why it's called on-demand self-service. So whatever way you need infrastructure, you should be able to go and click on that. It will be available to you. So these are the first 4 important attributes of cloud computing. And that's what I put in part of my definition also. Any business service which is available over internet, so broad network access, which is scalable, so rapid elasticity, which charges you on a pay-as-you-go model and available on demand. Now, I hope you understand that my definition would be more mix of the what you saw on the Forrester, what you saw on the NIST. These key attributes are defined by the NIST, and we normally follow the NIST as a standard. But to clear our concepts, this is the how cloud computing is defined. Coming to the 5th key attribute, resource pooling. Now, before I go there, how many of you have used multi-tenancy, or how many of you know about the multi-tenancy? Anyone? Some question over here? Anyone? So, what do you know about the multi-tenancy? Not the 100% right answer. I would say multi-users accessing a given resource. I would not 100% agree with that. Kind of a thing. Let me explain in a way. I'll start again with the best way, starting with an example. In India, we have 3 largest private sector banks, HDFC, ICICI, and Axis. Now, they want to, I believe, I'm not sure which software they're using. I believe they are using Finacle. Finacle is from Infosys. So they are using Finacle. Now, in this case, they go to the Finacle or Infosys, say, we want to use your environment. We don't want to use in our infrastructure. You should be hosting your Finacle in your environment only. But ICICI says, when someone comes to my homepage, www.icici.com, it should first show him all the promotions and the offering like cards, loans, everything over there. It should have my logo, it should have my customization part over there. HDFC says, when somebody comes to my page, it should have just a plain login page first. When he logs in, it would show him some other alternatives over there. Plus my logo is mandatory. Axis says, for me security is more important. So when somebody comes to my page, first thing it should show all the security warnings, the requirements and all that. Then he can click on the next page where it shows the offers as well as the login page, both on that. For Infosys, they are offering a only single software like all of Finacle. Now, how can they offer? So that might be hosted in a Infosys data center only. Now, when it's hosted in a Infosys data center, in that case, they can configure that if they had made, I don't know about Finacle, but if they had made in such a way that only they need to configure certain pages or create a certain business rules in their applications, such a way that single application is being served to the Axis Bank, HDFC and ICICI. When somebody hits ICICI.com, based on the URL, it's hitting over Infosys Finacle, it would show the promotion page of the ICICI. When somebody hitting the HDFC, it would show the HDFC page of the login. Or when somebody hitting the Axis, it would show the page of that Axis where it will be like, it will show them that, okay, this is the your security warning page. So single software serving them, or single, again, I'm not always sure that a single is the right word to use, because it can be a multiple versions also, because that's a different possibilities coming. But just going in a little easier way, a single software configured in such a way that serving to the different organizations differently. So as an end user of Axis, I would see different page. As an end user of a ICICI, or you might see a different page. As an end user of HDFC, you will see a different page. In this case, HDFC, Axis and ICICI are called the tenants, and we are the end user of the tenants. So tenant is nothing but a group of the users or a combination of a multiple users. Because we normally go, you log into any applications where it's a single end user application where multiple users can configure over there. It may not be a multi-tenant system. Why the tenant is important word here is a system may be configured as per the tenant. So all the users of the tenant would see the same application. So here all the users of Access would see the same application, all the users of HDFC will see the same application. That's the concept of the tenants. And now when you make a multi-tenant system, it should be having the using the resources effectively. So a multi-tenant system offered to you where the resources are optimally used using the resource pooling. So you have a 20 GB RAM machine, it should be optimally distributed. That's something 4 GB RAM machine to one user, 4 GB to another user, 4 GB to third user, 4 GB to fourth user. In a way it would be. So optimal resource pooling should be happening with that. And that's also one of the key attributes, because generally what happens when you go for a normal environment, you try to do a little higher side only estimation. So you go for a 20 GB RAM machine, you need a 4 GB, you will go with a 20 GB considering I may have a requirement in the future. In a cloud, resources are optimally used using resource pooling, and they achieve the multi-tenancy with that. So these are the 5 key attributes of the cloud computing. And that's why I'm taking a much more time than anticipated. My only reason for this is because some of the things coming slides would be a self-explanatory, you can just read and skip. But this is the concept you need to understand very well. So I'm focusing more and more time, spending more and more time here. So that's why I wanted to know, are you all clear with this concept? Are you all clear with the definition of cloud computing, definition of 5 key attributes? Any doubts here? And I need yes from everyone. So I would request everyone to say if you are clear. If you have any doubts, do let me know. If you are clear, let me know. Because that's the key aspect, because why you are here? You are here to learn the cloud computing. So now when you go out in the market and somebody says, I'm using a cloud computing, you can counter-attack him and saying, is it satisfying all the 5 attributes? How are you achieving those 5 attributes? You should be able to answer. And somebody, if in an interview say, somebody asks you that, what is a cloud computing? You don't need to mug up the definition and say, you just need to mug up this, that it's a business service which is offering these 5 attributes. So in a simple definition of a cloud computing, any business service which is meeting the 5 key attributes of the NIST is called a cloud computing. Now, a few examples of our different models. So if you see the SaaS models, a few examples like a Google Docs, Salesforce, Oracle as they're offering, the Office 365 Live, Lotus Live, those are the available where you can directly consuming the service. So that's the SaaS models. In a past, we have a Google App Engine, Force.com, Heroku is there, OpenShift is there, TIBCO is there, Microsoft started Azure with the PaaS only. So a lot of things available in a PaaS model also. In IaaS, Amazon is leading the competitors by the margin. The nearest competitors I would say there are 2, Microsoft or other 3, Microsoft, IBM and Google. They are coming up very strongly, but Amazon is still leading the race by the very good margin. So these are the different examples of the cloud service providers. Now on the cloud delivery models. So when you see there's a software as a service model, the software is offered to you as a service. Software something available to you. Excuse me. Just a second. So now, in a software as a service model, would be your end users generally would be, it's a SaaS model. So your end user would be normally consuming, whether you are technical, non-technical, does not make a difference. Your end user would be like that. In a PaaS model, it would be normally for the developers, application owners who want to develop their application or host their applications, they would be using over there. In AWS model, it would be generally going in a way where the people, either they want to create their own cloud, in that case the IT people would be coming, or as a developer you want to host your application on a cloud, you can use the AWS. So those are the consumers over there. Now what is the coverage they are doing? It would be that we can see that's okay. Examples like we saw previously also SaaS, CRM, emails. But on the AWS side, it provides the virtual caching, virtual memory, virtual server, virtual environment over there. Also on the PaaS model, it will be application over there which would be offered to you. So development web, those are the cases of the SaaS or PaaS over here, or who would be using those services. Now a few simple use case for the cloud would be where it's more popular. So infrastructure transformation, people are moving the existing infrastructure to cloud. It can be private or public, anywhere they're moving completely over there. SaaS collaboration are taking more and more. So in Gmail and the Lotus Live or Outlook, or even for collaboration, WhatsApp and all that, you can see, or even then there's a Google Talks, or even if you see the WebEx for the your sharing and everything. Cloud is ideally fitted for the dev and test, because it's a pay-as-you-go model. Just to take an example, you have a 16 GB RAM in a production. Now if you want to do a load testing, how would you do that? Either you procure another 16 GB machine to do a similar kind of environment, or you can go to the cloud, use 16 GB machine over there, run for 5 hours, and you pay only for the 5 hours cost. This way it's much cheaper. It's best for the hosted solutions. So for hosting of websites, I also see that how many sites are in Amazon, which will give you my redeployment point. Content delivery is one of the key aspects. So Akamai, Amazon as a cloud front, those are the keys where for the faster streaming and the faster content delivery, it's becoming more and more. High performance computing, so many labs are using that for the research and computing, because Amazon can provide you GPU level infrastructure to 44 GB RAM in a few minutes. So that's where dev and test like POC is also one of the immediate case where it will be very helpful. It's very helpful for the backup. You can set up your disaster recovery in cloud, and I'll explain more and more detail on day 7 how Amazon is best fitted for backup and DR. The VPC, or you want to make your private subnets, that's for the more security aspects. I'll say something more when we go more about the day 7 over there. Now which verticals are highly using this? So communication and media are highly using. Even this, you see this, this election results, they have used, so many of you are using cloud effectively, either for streaming, either for hosting, for some other debates and everything. They are using this very well. Education is one of them, like Edureka is using, and so many are using the cloud. Banking is still lacking because of considering the security requirements, so they are more in a private cloud or the legacy systems, but they are gradually moving to that. Healthcare is also in an initial stage, but slowly they have started exploring more and more in the cloud era. Manufacturing is one more aspect about the machine-to-machine communication, where the cloud, or for more about the big data, they are using cloud. Insurance is one other where the people are started moving to cloud for testing and everything. So this is the verticals where they are using more and more cloud. Now the one thing which I mentioned, who are you and whether cloud is right for me or not? You are a Java, .NET, PHP, Ruby, Python, any kind of a developer. You are an IS skill with the Windows network, virtualization, VMware. Everyone, the cloud is useful. You have something available in cloud for you. Now, considering that, even Amazon has something available to you. So when we progress, I keep on saying different availabilities, what you can use as a admin, you can use the Amazon for. So again, we talk about the vendor lock-in, lock and lock. So cloud has started a little open source movement. So open cloud movement has started, where it's more about the open formats plus the open interfaces are there. And it's not only open source, but open formats are coming. OpenShift is one of the case. OpenStack is one of the case. So these are the cases, few cases I have listed here. CloudStack, Cloud Foundry, OpenShift, OpenStack, Eucalyptus. These are the open source movement started in a cloud arena. So their major focus is standardization of the APIs or the services, so vendor lock-in should not be a problem. Now I talk about all the goody-goody about the cloud. So before I go to the concerns, any doubts or questions? So a good point from Ashok. What is OpenStack? So OpenStack is a service by Apache or the standards available which helps you to make your own cloud. Now it's not like a virtualization environment or hypervisor, but it uses hypervisor to make your private cloud. So it provides an API, so using that you can use any of the hypervisor and make your own private cloud, something like Amazon on your own environment. So OpenStack is for that. And like Linux we know we have a lot of flavors like Red Hat Linux, SUSE Linux, Apache or the Amazon Linux. Same way, slowly for the OpenStack also various flavors have started coming out. One of them is Red Hat Linux, Red Hat OpenStack, which is being supported version from Red Hat. There are different versions, and sure, in a few while you will see different versions of the OpenStack also in the market. Yes. So, question: what is vendor locking? Vendor locking is something where you are hosted your application or you are consuming service of one of the vendors. You can't move to the another vendor easily. It's not interoperable. Like best case is a .NET. So you have created your some application in VB. You can't host on every machine. It cannot run with all the servers. While Java is a interoperable. You just need a Java environment and it would start executing. So that's what the kind of a concept of vendor locking. It's something interoperable or not. So yes, Ashok, you are right. If you are using OpenStack, you may not need the Amazon, because the OpenStack would work as a private cloud. But then the comparison of private and public cloud would come in a picture. So as I said, we already compared the risk and benefits of both private and public cloud. With the private cloud, you would have a limited resources. Public, it's a massively scalable. Plus, lot of the things you need to manage. Lot of the ROI, you need to calculate everything over there for the OpenStack. You get more security and everything control over there. Amazon provides you a lot of other advantages over there. The vast service offering from Amazon nobody is having service offering like that. So that's the difference between Amazon and OpenStack. Moving on, concerns. So people definitely have a little concern on the cloud. So there was a little survey a while back, and the people said what holds them back to moving to the cloud. One of the major worry for them is a security. Another worry is a control. We saw that. Expertise, that team might not have expertise. Compliance, whether the cloud is complying to the certain standards or not, whether it's mature or not. So those are the things which hold them to move to the cloud. Now coming to another is a concern part is what are the concerns? So loss of control is definitely. Integration, how do you integrate your legacy application over there? So if you have something in a mainframe, how do you move it to the cloud? Whether it would support or not. So that's always a worry for people. Same is the interoperability. I just talked about the vendor locking. Then whether it would work with all UIs or not. Accessibility part, whether cloud is available on all UIs, whether it works with everyone, whether it's accessible over everywhere in the world. How is the reliability and performance? Since it's I would say your cloud is as powerful as your network. So if your network is not powerful, your cloud would not work well. So whether it's reliable, how much performance it would give, those are always worry for them. Apart from that, you have the policy and compliance concerns, like whether it's complying to all the security or governing requirement of my organization or not. How does it take care of the breach and forensics? What are the security mechanisms they implemented? What about if the cloud is down? And cloud can go down, right? It has happened with Amazon also a couple of times. With Twitter, it has happened in the past. Google, it has happened in a couple of times. So it's just a business surprise. If cloud is down, what would happen? It can support more logins. In that case, how would it work? It's also a consequence of a creative destruction. If a tenant does something which can harm the infrastructure, so whether cloud providers have taken right measures to to prevent any tenant to avoid this destruction. So those are the definitely concerns for the people, because at the time when you are hosting somewhere on a cloud where the other tenants are also hosted, you always worry for them. And with that, there is a very good articles available. There is a group form called Cloud Security Alliance, CSA. It's an open group where the major cloud providers and the quite a major organizations are also part of that, and they are working on the security of the cloud. So they've come out with the, and as we so see, the cloud is definitely, the security is one of the prime concern for everyone. People hold back to moving to the cloud because of the security or privacy concerns. So considering that, the Cloud Security Alliance has come out with the Notorious 9. There is a white paper on that. They've written a white paper on that. You can't see in your screen, but there is a link given in this PPT. So when you receive this PPT, there is a link at the bottom of this page. You can directly, or you can just Google on Notorious 9 by CSA, Cloud Security Alliance. It would give you the list of all these 9, where they've explained all 9 in categorically, plus how do you mitigate this, they've also explained that. So if you are thinking for a cloud, you should start with this, or you are thinking for a cloud security, you should start with this. You should go read this white paper thoroughly. So cloud, definitely we know it's a good, the security issues are there, and then people are holding back for the security. But to tell you frankly, security is not the prime concern. Again, I would say reason. See what the public cloud providers do. They have the right resources. Resources means money, power, infrastructure, manpower, everything they have right to ensure that they have the right security mechanism available. So you would find very less data theft cases with Amazon, Google, Apple than anyone else, because they understand the power of the security. They know security is a prime importance for everyone, and if the security is breached once, they will lose the trust of their half of the customers. So they do take care of this very well. They provide all the mechanism to ensure that security breach does not happen. Even this, the Heartbleed which happened last month, the Google was one of the reason why they found this. Everybody started working on immediately, and then immediately applied the patch before anyone else can. So that's the main case for this. So cloud, if you see, it's a cheap, scalable, small startup cost. At the same time, your hardware failure, not mature, would be always a worry. Security is a worry. So you need to balance out how it works, and based on that, your requirement, you need to plan for the cloud. If you are moving from your product to service, now when you're moving to the cloud, you're moving from a product to service. So you need to plan your pricing models. You need to understand what is the right fit for you. How do you meet your requirements? How we are going to implement the SLAs or security requirement? Are you going to use any cloud services or the private cloud? How are you going to use the brokerage part of that? So a lot of things you need to consider while you are doing the migration to the cloud. Whether you are making your own cloud or you're migrating the cloud, you need to consider a lot of points as part of this. So with this, I bring end to the cloud computing overview.